Hello, Advanced Algebra 2 students. This is Coach DePaulo back with a video for lesson 6.5. Today we are going to learn to factor cubics and quartics. In our lesson 6.4, you saw what a cubic graph looked like, and you saw what a quartic graph looked like. So just as a reminder, let me show you real quick. Okay, so if you remember, okay, here was a cubic graph. It had two turns. It had a x-intercept, one x-intercept. This one did, but if you remember, if I went back and changed this to minus 0.5, then we ended up having three x-intercepts. And so that means that this equation has three solutions. So one way to find those three solutions is by graphing in Desmos. Okay, also, what did a quartic look like? So here is a quartic, and now this one is a little bit harder to see all of the turns in one screen, just because it starts to get pretty small. But as you can see, we have up there around 0, up there we have around 40, we have a turn, and down here around -10, we have a turn, okay, and then further down here around -140, we have another turn. So there's a quartic with 4 turns, and it also has 4 x-intercepts, okay, and there they are, and so there are 4 solutions. Okay, so what we're out to do today is we're out to factor these and solve them algebraically. We can do that in a certain instance. We can factor what we call sum of two cubes if it's cubic, and also we can talk about quartic. We're only going to talk about cubic here in part 1, and then in part 2 I'll talk about the quartics. So before we get started, and if you're watching this video, you're in luck, because I'm going to put, if you are in class, we're going to be doing a warm-up. I'm going to put that warm-up here on the video. So what I need you to do is I need you to take out a sheet of paper, and I need you to label it warm-up 1-30-24. I'm going to pause this real quick. Or I'm going to run to my settings, and I'm going to turn on my airplane mode so I don't get a text in the middle of the video like I did yesterday. Okay, so here's what I'd like you to do. I'm going to give you an equation, and I want you to factor it synthetically. Okay, so the first one up is going to be x cubed plus 8, and I would like you to divide that by x plus 2, and I'd like you to do that synthetically. Okay, so I'm going to help you with this, setting it up and doing the synthetic, but then what I want you to do is we're going to do 3 of these, and I want you to try to find a pattern. Okay, so first thing we're going to do, step number 1, is we are going to set the divisor equal to 0. We're going to solve for x. Step number 2, we are going to set up our synthetic division box. So I've got -2, okay, and then right here, here's the largest exponent with a 1 out front. So we're going to put a 1, and then I have 0. I have a 0x squared plus a 0x. So I'm going to put 0, 0, and then an 8. So I'm going to pause this video, and what I want you to do is I'd like you to synthetically divide that, and then come on back when you're done. Okay, so I hope you're done, and let's see. If we brought down the 1, -2 times 1 is -2. Add that up, we got -2. -2 times -2 is 4. Add that up, and we get 4. -2 times 4 is -8. Add that up, and we get 0. Okay, so we know that the two factors of this are x plus 2 is a factor, and then the answer, which is another factor, is x squared minus 2x plus 4. All right, here we go. Here's your second warm-up problem. I would like you to take x cubed minus 27, and I would like you to divide that by x minus 3. Pause the video, give it a shot, and go. All right, let's see how you did. Let's see. Step number 1 is to put x minus 3 equal to 0. So x is equal to 3. Okay, so then we've got my division box. I got a 3 outside, and I got a 1, a 0, and a negative 27. So I'm going to bring down my 1, multiply that by 3, add to the 0 and get 3, and then 3 times 3 is 9, and add that to the 0 and get 9, and then 3 times 9 is 27, add that to the negative 27, and I'm going to get 0. Okay, so what are the factors? The factors are x minus 3, and then because I got a 0 remainder, the other factor is x squared plus 3x plus 9. All right, we're going to do one more. Okay, we're going to do one more example. And actually, this was example 1, and this was step 1. So I'm just going to erase that. You don't have to if you don't want to. I'm just going to erase that, though. All right, erase that. Okay, here we go. One more example, or one more problem to try, for our warm-ups. Again, this is just a reminder on how things are on synthetic division. Let's go with, goodness, what are we going to go with? Let's go with 1 minus x cubed, and let's divide that by 1 minus x. Hello. Okay, so what do we got here? This is a strange looking problem. Okay, so we didn't do one of these while we were doing this lesson, but I'm going to show you how to handle it. What we need to do is we need to go ahead and rewrite this as negative x cubed plus 1. And then we are going to divide that by negative x plus 1. And now the steps are the same. Okay, so the first thing I do is I take negative x plus 1, I set it equal to 0. Get negative x equals negative 1, so x is equal to 1. So that's what's going to go outside my division bar, or my synthetic division bar. And then I'm going to put in a negative 1, and a 0, and a 0, and a 1. Okay, here we go. Step, bring down the negative 1. 1 times negative 1 is negative 1. Add that up, and I get negative 1. And then I get 1 times 1 is negative 1, and add that to the 0, and I get negative 1. And then 1 times negative 1 is negative 1, and I add that to the 0, or add that to the 1, and I get 0. There we go. So what do we get? Well, our factors are, okay, and I'm going to use the new one. My factors are negative x. My factors are negative x plus 1, and the answer is negative x squared minus x minus 1. Now, to help you out just a little bit, okay, I'm going to pull a negative 1 out of here, and I'm going to get negative 1 times x minus 1, and I'm going to pull a negative 1 out of here, and I'm going to get negative 1 times x squared plus x plus 1. And then remember, a negative 1 times a negative 1 is just a positive 1. So really, seems weird, but I can actually just ignore those. I can just ignore those. And we'll talk about more of that later. So now what I want to do is I want you to pause the video, okay? And I'm going to zoom out a little bit. And what I want you to do is your goal is to find a pattern between these two terms of this factor and these three terms of this factor. Okay, again, what is a relationship between those two terms and these three terms? And then that same thing should apply down here. I want you to pause the video and I want you to give it a good 5 minutes because that's what we're going to do in class. And again, I want you to try to find the pattern between this term and then these three terms right there. Okay, again, pause the video and give yourself 5 minutes. Okay, so what'd you figure out? Okay, what did you figure out? Let's go and back to our notes now, and let's see if you figured out the pattern. So if you look, one of the examples that I gave you was this one right here. And when we did that example in our warm-up, it turned out that the factors were x plus 2, because I gave you that one. And then after you factored it, the answer was x squared minus 2x plus 4. Okay, and here's what I was hoping that you would get. And let's see if you did. Some of you probably are gonna get it. Okay, if I take this term and I square it, I will get this term. And if I take this term and I square it, I'm going to get that term. And then how about the middle term? Well, if I multiply these two together and then subtract them, I get that third term. Okay, so let's see if that works over here. If I take this term and square it, I get x squared. If I take this term and square it, I get 9. And then if I take this term, negative 3, times this term, x, that's negative 3x. And then if I subtract it, I get plus 3x. All right, and then that last thing that works down here too. Square x, you get x squared. Square negative 1, and you get positive 1. And then multiply negative 1 times x, and you get negative 1x. But then if I subtract negative 1x, I get positive x. So that's the pattern we were looking for. What's that mean? Well, that means that if you have a binomial where the first term is a perfect cube and the second term is a perfect cube, we have a pattern for that. And here is the pattern. The pattern is u plus v times u squared minus 2u v plus v squared. Sorry, not uv. Oops. Let me try that again. Okay, it is u squared minus uv plus v squared. And then if you had a difference of two cubes, then the pattern turns out to be u minus v times u squared plus uv plus v squared. All right, well, question then is, where does the u come from and where does the v come from? Well, the first term is u cubed, so u is equal to the cube root of u cubed. And v is equal to the cube root of v cubed. All right, so let's go down here to our practice, and let's put that into practice. Okay, here we go. First off, do I have a sum or difference? I have a sum. Secondly, is x cubed a perfect cube? Yes. Is 125 a perfect cube? Turns out, yes. Okay, so what is the cube root of x cubed is x. This is our u. And the cube root of 125 is equal to 5, and that is our v. So if I factor this, then my factors are going to be, remember, up here, for a sum, it is u plus v. All right, so I'm going to go ahead and minimize that a little bit so you can see it. So u plus v will be x plus 5. Then, if you can look up there, you can see the trinomial is u squared, which will be x squared, minus uv, which would be 5x, plus v squared, which would be 25. Now, just so you know, college note, this will never be factorable. Yes, it's got a square, got a perfect square there, but this middle term you can never get to. So in a second, when we get to solving, we're going to set this factor equal to 0, but we're going to have to set this factor equal to 0 also and use the quadratic formula. So let's do one more of these. We're going to do number 4 because it's a difference equation. And then, and also I'm going to show you how to solve. Okay, so we're going to take care of the difference and the solving at one time. I know I need to solve because it has an equal sign. And then I'm going to remind you about grouping because anytime we have a cubic, but there's 4 terms, we're going to have to group. Okay, let's get busy. First off, is 3x cubed a perfect cube? Nope. Is 24 a perfect cube? Nope. But I can factor out a 3, and then I get x cubed minus 8. Now, x cubed is a perfect cube, and 8 is a perfect cube. And remember, since we're solving, there's no variable in there, so we won't have to use that 3 anymore. That only affects the graph, not the solutions. All right, here we go. The cube root of x cubed is x. The cubed root of 8 is 2. So, again, minimizing. Let's see if I can do this enough. There we go. I know I'm writing small down there, but I wanted you to be able to see the formula. Okay, so look up there for your formula. Okay, so what is going to be my 2 factors? My factors are going to be x minus 2 times x squared plus 2x plus 4 equals 0. So there's me factoring a difference of 2 cubes. Now let's solve. Okay, so we've got x minus 2 equals 0, so x equals 2. There's one solution. Okay, over here, a is 1, b is 2, c is 4. So I'm now going to use the quadratic formula. First, the discriminant is 2 squared minus 4 times 1 times 4. So that's going to be 4 minus 16, which is negative 12. So x is equal to negative b plus or minus the square root of negative 12 all over 2a, which is 2. Okay, I can break this up. I can break this up in the negative 1 times 4 times 3. So I'm going to have x equals negative 2 plus or minus 2i square roots of 3 over 2. And then this reduces and this reduces, so they all reduce by 2. So x is equal to negative 1 plus or minus I square roots of 3. So there's two solutions. So let's put these in set notation. Here we go. X such that x is an element, negative 1 minus I square roots of 3, negative 1 plus I square roots of 3, and 2. All right, last thing before the notes are over, let's go over here and let's factor by grouping. Okay, remember step 1, I'm going to group the first two, make sure there's a plus sign, there is, and group the second two. Next thing I'm going to do is I'm going to factor out what they have in common. Okay, this first set I can factor out a 2, nope, I can only factor out an x squared. So that's going to leave me 2x plus 5. Okay, remember over here, I can't factor anything out, but you have to at least take out a 1. So we're going to factor out a 1 and get 2x plus 5. So when I factor these, my final factors are going to be 2x plus 5 times x squared plus 1. Okay, and then that's all I'm asked to do. I'm not asked to solve because it doesn't equal 0. All right, so that's the end of 6.5 Notes Part 1. And I hope you have a great night. And if you need help, come on into Mega Lunch. Me or Mr. Spence can help you out. Have a great day.